Hi everyone, today let's talk about the LeetCode problem 31, Lex permutation. If this is the first time you heard of the Lex permutation, you may wonder what is the Lex permutation. There's a great YouTube video explains what is the Lex permutation. I post the link in the description of this video. You can check it out if you are not familiar with what is Lex permutation. Now we go back to the problem. I will explain to you what is my understanding of Lex permutation. Here on the board, there are two numbers. I can tell you now that the second number is the next permutation of the first number. There are some things you can observe here. First thing is both of them are consistent by the same set of digits. Second thing you can observe is the order of those digits is not same between them. Third thing you maybe observe, but it's not that obvious, is the second number. If you're trying to generate a number with all these digits, the second number actually is the smallest one, which is larger than the first number. These three attributes of Lex permutation are very important. First attribute is you have to use the same set of digits. Second thing is the new number must greater than the current number. Third thing is in all the number you generate with all the digits, the next permutation is the smallest one, which larger than current number. So here, our solution is actually trying to generate the number by these three attributes. Now let's see how can we generate the Lex permutation. Let's observe these two numbers. If you read it from left to right, you will see the first number, the first digit are not same, is 3 and 4. And we look at the first number, we read it from right to left. The digit is 1, 4, 5, 6, and 3. We observe here 1, 4, 5, 6. They are in an increasing order. And 3 is the first number, not in increasing order if you read it from right to left. So here we find 3. We need to switch it with one digit on its right side. So in this result, we saw it switch with 4. Why we switch 3 and 4? Because 4 is the smallest number, which is larger than 3. Now let's switch digit 3 and 4. Let's see what we get right now. This is the new number after we switch 3 and 4. The third step is we are going to sort all the digits on the right side of 4. After we sort all the digits on the right side of 4, we get the exactly answer we need for the next permutation. Below it is the code block. The code is just simulate all the steps we just introduce to generate the next permutation. Now let's go over the code to see how do we tangle it. So as I said, first step is we are trying to find the digit tree here. So we start from the index on the rightmost side, and we compare the digit, the previous digit. If it's smaller than if the current digit is smaller than its previous digit, means that it's not in natural order, in increasing order anymore. This is the step 1. And here we have a if check. This is not mentioned before. So this is to deal with one color case, which is like you cannot find the digit, the first digit not in increasing order from right side. It means like you can see here 1, 2, 3. All these 3 digits, they are in increasing order if you read from right side. And the next permutation of it is actually 1, 2, 3. You just reverse all the digits. It's like a cycle. After the last permutation, you rotate to the first permutation. And here we have step 3, step 2. So let's say what is step 2. Step 2 is trying to find the number 4, the digit 4. How can we find it? As I said before, we're trying to find the number 4 on the right side of digit 3, and is the number which is larger than 3 but close to 3. So even 4, even 6 and 5, they are larger than 3, but they are not the closest one. We need to find the closest one and larger than 3. So now we find both 3 and 4. So the step 3 is like we will swap 3 and 4. Now we get this. As I said, the last number, last step, we will sort all the digits on the right side of 4 in natural order. So after we do it, we get 1, 3, 5, 6. So this number, all this sequence, is the answer we want for this problem.